Welcome, my name is Maciej Łukiański. I come from Poland. I work in Droptica, and I will tell you today about Docker and Drupal and how we use it, and we encourage you to use it because it's really helpful and it's really making your life easier. Before I start though, I want to invite you to an event that we hold every year in Wrocław. It's a Drupal Camp there. Wrocław in May is fantastic because it's sunny, nice city center. We have vouchers for a free beer every year, and usually there's a grill and loads of fun, and we try to have international guests as well, so please come over. It's drupalcamp.pl is the website. You can check it out. It's still about the Drupal Camp from the last year, but probably around January we're going to start preparing it for the new one. This event took place already six times. So we're going to have a 7th edition in May. It's not far.
That's right.
It's really close, so please come over. Okay, coming back to my presentation about Docker. Who used Docker ever? Who uses Docker on a daily basis? Perfect. Who doesn't know what Docker is? Very, very well. Okay, so starting, usually we have, like when we were deciding on Docker, we were looking for various solutions. We had these various problems that probably you also experienced during web development. Working with Drupal, you have multiple stacks, like with Drupal 8 working on PHP 7, some old weird sites are still on Drupal 6, which will not work on PHP 7, that you have to use PHP 5.2, which is not even supported anymore. You have many versions of libraries, many other services that you use on your projects, Apache Solve from 4 to 6, depending on the project you're currently working on. It's really difficult to maintain all these things on your local machine when you develop. So when a new person comes on a project and you tell them, okay, this is what you have to install, and they're like, okay, I have Apache 5, Apache Solve 5, I have to now downgrade to Apache Solve 4, or I have PHP 7. Now, how do I move to PHP 5.6 or some other? And there are many libraries, versions of libraries, some libraries that convert HTML to PDFs, or some other libraries that a particular project might be using. You might need Redis, Memcache, MongoDB, all the other services that a website might use for some reason. And they also have versions, and also maintaining them is really difficult. I mean, installing Apache Solve takes some time, right? And then making sure it works correctly, copying over configs into the correct places on your machine, that also takes ages, right? And it's just a pain. So this is one problem. Another problem are complex projects, right? We have systems with APIs, microservices, some other legacy systems on some outdated stacks that are even often difficult to reproduce on a machine. And there are these questions: how to onboard developers quickly? If you have a project that lasts for 2 years, it takes 3 developers, there's a great certainty that people will change on the project. People take leave, take sick leave, they move. The project has to be running every new person. People reinstall their software on there because you had, I don't know, Linux 14.4, now you have 16.4. You bought a new machine, and every single time you have to upgrade your local development place. Also, you have all the other development environments somewhere on the servers, some dev environments, test environments, often multiple test environments. For example, if you use branching and feature branches, which sometimes take longer time and they're tested separately, you might have multiple instances of environments. And they all of them have to be set up. They have to be maintained. You have to make sure that they work. You have to know that they use the current versions of libraries, PHP that the project is using. Say, for example, you build a website which, I don't know, converts this is a good example actually, which converts HTML to PDFs, and it uses a library. And then at some point in time you decide, okay, let's upgrade this library because a new version offers greater functionality. How do you propagate this to all these environments? How do you make sure that everybody now has the latest version of this library? How do you do that? So there are many approaches. How do you tell everyone on the team to, okay, please upgrade this version of a library or some other thing to a new version? If you change Sol from 4 to 5 or to 6, how do you have to tell everyone, okay, now please everyone upgrade. You have to go to each single environment and upgrade the environment. How do you do that? There are actually many solutions, not only Docker, and we probably went through all of them, really. So the first solution is use everyone's local setup and hope it works. So Drupal is really great. It will work often on PHP 5.6 and 7.1. If you use Drupal 8, it will, like, you can install it and it will work, right? And you can hope it works, and then if you move it to production, there's some other version of PHP there. Most of the time it will work, but every now and then you will get a fatal error for some reason, for some incompatibility. If your version is PHP 7.1, it's really easy to write code that will not work on PHP 5.6 already if you write your own custom module. So, and yeah, we've seen these things happening. Then you can manually configure, upgrade, down, or upgrade each machine. This is a tedious task and takes ages. I mean, some projects, especially if they are complex, it might take 6 hours a day to set up your own machine to actually work on a project which uses multiple various services. And this is, and it's money. If you like, time is money. So if you tell a client, okay, we can onboard another person, but he will be able to start working tomorrow, and you have to use a whole day of his work to actually just get him up and running. It's not great. You have VirtualBox. Anyone use that? VirtualBox and also Vagrant, which is a VirtualBox really. You can walk around many of these issues with that, using even Puppet, Chef, or Ansible to automate setups. Now, this is a better solution. Many people use it. It works often. Sometimes it breaks as well. I mean, we used it. We moved to Docker. We think Docker is, you have remote workspaces as well. So you can use Amazon or some other service that sets up remote workspaces, and you can set up these environments there, and one person can maintain them for the whole team. It's probably easier than everyone doing it by himself, but it's pricey. And then you have Docker, which we are using for 2 years now, and we can't imagine going back, to be fair. It really changed the way we work. It gave us so much that I actually decided to come here and tell you all about it so that you can try it and hopefully, benefit, because it really helps. These are some of the achievements. So we estimate we probably save about 500 hours a year. We're a 20-person development team, right? We estimate we probably save about 500 hours a year because setting up a new project takes 10 minutes. It really does take 10 minutes. If a new person joins the project, they actually just type in 2 or 3 commands into the console, and they have a full working environment with all these other services that usually took ages to set up. Like Sol, you just have it. Like one person prepares it on the project, and then it just works for everybody else. And all the other Node, Postgres, other services, we don't have any differences between environments. So we don't have these problems where you had this version of PHP, I had this one. It worked on my Linux version, it didn't work on yours. We kind of just don't have these problems. And yeah, we don't have this, it worked on my machine. It doesn't really happen right now. And it generally works. Like with Vagrant, we had many situations where suddenly for someone it just didn't work. You upgraded, you pulled in new release, you pulled a newer version of a virtual machine. Suddenly Vagrant didn't work for some reason. Some of the projects just didn't launch, and you had to investigate, and and so it worked yesterday, suddenly didn't work today. we don't get these problems with Docker. It generally just works. And we also noticed some other benefits. We actually, because setting up a project takes so little time now, we can have these cross-functional teams where, for example, somebody is really good at setting up search with Search API and Search API Sol and all these custom settings. So he can actually just onboard on a project, set this up for everyone, and it works, and it's easily propagated to all the other environments, to all the other developers, and then to production as well. Microservices. This is, well, it's not even a new trend anymore. More and more Drupal is just not just Drupal. You have many other things. Like Drupal is great, it does many things very well, but there are services designed for certain things that are just doing them quicker. For example, we use this, for example, in a scenario where we had to send many emails at a particular hour to all the customers, because they expected to receive their email between 4 and 5 in the afternoon, everyone. So you can't use Drupal cron for that, because it will just every 5 minutes batch up, 100. You just won't make it if you have thousands of customers. So we kind of just used the microservice where Drupal was just sending information which users should receive emails, and a different service was just picking it up and sending it out. And all sorts of other, and also what we are experiencing is that experimenting with a new technology that you have never used with Docker is much easier, because you don't have to read a lot of documentation to start. So for example, I recently wanted to try out Node.js to see, to write something in Node.js, and you can just type in Docker Node.js in Google, and you immediately find the Docker Hub image, pull it down, you have Node.js in it, you can launch it, and it just works. Same with Apache or Apache Sol, Elasticsearch, all these services, they have Docker official images, and they just work. Like, you don't have to configure, download, install, read all the documentation, and it doesn't work for you. You've never used it. You have to spend a lot of time tinkering with it. With Docker, these services basically just work like magic. Okay, so I'm going to gloss through it because everybody knows what Docker is, right? Docker allows you to kind of wrap up a piece of software in a complete file system. So basically, it kind of works like this, where you have an image which contains a complete file system, and you can run a process on this file system. So you can have a complete image of Debian with Apache on it, and you can run Apache on this system. And the way it works is Docker separates the host system from the Docker images and from the containers that run on top of the Docker images. So moving further, I'll show you how we do it. Has anybody heard of Docker Compose? Okay, very well. So we use Docker Compose. We use boilerplate images that we prepared for Drupal. They are really good. Like, they're all open source. I'll show you links later. So we kind of use images which are pre-prepared to run Drupal, and we use a Docker console, which is our custom script, which also speeds development in, like, we have a workflow that we invented over the years, and Docker console helps us work in this environment. So firstly, Docker Compose. Docker Compose is a YAML file which allows you to describe a complete setup of Docker containers. Because usually in Docker, you should, the best practice is to run one process on one container. So if you have, like for Drupal, you have Apache, usually, MySQL. that would be two separate processes. You should use two separate images. And basically, you just describe, like we have our own namespace on Docker Hub, and we use Apache PHP, and this is version PHP 7, and we use MySQL 5.6. This is a separate image. And that's just that. With this, like in here, I do some more things. You can, just like in virtual machine, you can have your local folders mapped onto like local file system folders or files mapped onto the files within the Docker image. And these are the links. What links do, they just create an entry in the host table on this image, which links into this image. So on the net, in the private network that these images create, this image sees this image, and it can connect to MySQL. Apache can connect to MySQL. And these images are often enough to start up a website and actually just use it, and it will work. I can actually demonstrate you really quickly here. This is my demo app that I created for this session, and there's a Docker Compose here. It's a bit simpler. There's a Drupal Apache image with Xdebug. I'm mapping the app, which is this is where Drupal is, Drupal 8. I mapped the whole directory into the Docker container. I gave it a virtual host decon demo, and I use MySQL, and I also use a PHP myadmin image, which also maps it to MySQL. So I have a separate image. That's an image which just gives me PHP myadmin. I didn't have to configure anything. It just works with the whole setup. Okay, and if I go to the console, right, being in this folder, I can just do Docker Compose up, and the images are starting up, and right, we can actually access the website now. Just leave the presentation. Okay. And I just created a very simple Drupal commerce store with one product on it. And whenever I did a request, you can see, like, these are logs straight from Docker, which are displayed on the screen here. And you can see that, I received this request here. It was at 200, so whenever if I refresh it, I get some more of those. So this is how Docker Compose works. You can use just Docker Compose. You don't have to use our console script to launch a Drupal on Docker. So it's enough to just specify a Docker Compose file, map your code, and you can immediately launch Drupal on your machine, and you don't have your and you can this is great because you can now here we have PHP 7. You could launch another instance with PHP 5, PHP 5 or 4, whatever you'd need, and you could have two instances running at the same time. And on different URLs, you could access different systems. So you could have a legacy system which is very old and uses some custom setup, and you could have one Docker image for that, and you could have another one running. Same with a database. You could have two different versions of MySQL for some reason, because on production on one system there's an old version, and you're migrating it to a new version. You could launch two instances of MySQL versions and just use them at the same time, and have a third image which can link to both of them and pull data from one and move it to another. And this is really easy configurable with Docker Compose, because you don't have to write any difficult commands. This is a really simple file, and it kind of gives you the whole setup of containers. Okay, I'm gonna stop this. Stop. There. Okay, it works a bit slower on Mac. It works a bit faster on Linux. Okay, coming back to my presentation. So you can start really easily by just using the images, using the one for Apache and MySQL and PHP, and using another one for MySQL. Once you get the hang of it, you can build very complex systems which are then easily replicable and easily reusable, and still fairly easy to read. And also, what is fantastic, you get loads of great stuff for free. Like, for example, here there's a fantastic image which gives you Let's Encrypt setup, which automatically renews your SSL every time it's about to expire, and it's for free, and it's easy to set up. You just kind of type in 3 lines of code. You don't have to set it up. You don't have to write your own script. It just works. We often use a separate image for crons if they are heavy and they need some custom settings. We have a separate image for backups, and once you set it up, if you move from host to host, wherever you go, you have an image which automatically can back up your complete website, and it sends the website the backup to. Well, we use Amazon for backups, and it's easily configurable, and it just later on it just works. And then, for example, here we also use Apache Solr, which we use very often. It's like our tool of choice with Search API for search on Drupal. And it just works. You don't have to set it up. You don't have to configure it that much. You just kind of launch it with 4 lines of code, and then once you set it up on one project, you just copy these 4 lines from project to project, and on each new project, you have a separate Solr instance which immediately works. Okay, so our starting images, they are all available on Docker Hub. We wrote, there are many more that we created over time. We have our Apache PHP image, our standard one, and they have tags. They have a tag with PHP 5, they have a PHP 7, 7.1, all sorts of versions with Xdebug or more, or without any other things, more prepared for production. PHP FPM if you're using Nginx. PHP developer, I'll talk about it a bit more in a second. We have a separate image for Codeception. I'll show it to you on this demo later on. It's really easy to use Codeception for tests with Docker. If you're writing tests, we usually use Codeception. You could set up a separate image with Bhat just the same way, or some other. We have a separate image for mail catcher. Probably most of you use email reroute email module for that, to actually not to send accidental emails to clients from a dev environment. There is a mail catcher module which we use a mail catcher image which kind of launches a sandbox mailing service in your browser, and this helps you also to use Codeception to actually test emails that they are going out and they contain correct, data. We have even an image for postfix, so if we can if a project needed send emails from in production from the server. There's an image. We use JMeter for load tests, also a separate image. And what is great, if you configure this image, if we created this image once, we can reuse it over and over again in the same way on new projects without having to manually set this over and over again. So it's just like you do it once and you have it for all the projects. Okay, so a typical setup like this would be, so even here, right, I showed you that we have our 3 images that were running. We had the Apache and PHP, we had PHP MyAdmin, and we had MySQL. But they're all in their own respective containers when they're running. If you have Drush installed in your console here on your machine, it will not be able to interface with the system, right? So, and you might have more tools that you use. You might have some scripts that you're usually running, and they will not be able to run because the database is actually like in a different machine. It's kind of like you had 3 VMs, and you try to kind of do something with that. So, trying to stay in line with the one service one process per container, and also not to kind of clutter containers, images with Drush and all the other tools. You know, maybe a SAS compiler, what I actually listed some of them, right? You might have some other tools. You might have a SAS compiler, you might have Gulp, so you might need all the NPM, Node.js stuff just to compile CSS, which you would never do in production. So, and also not to make these images too complex, we actually just create another image. We create another image, which is just like a developer tool. We call it PHP developer. It usually contains Drush. It might contain SAS and some other Ruby gems for compiling, NPM, Bower, Fabric, or whatever you might need. And we also created our custom script, dockerconsole, which is like a helpful tool for us to build. And it gives us like a server-like feeling. Like with dockerconsole, we, instead of having to focus that much on how Docker works, we kind of can more treat it as if we were on a physical server or a virtual server, which everybody is a bit more used to probably, at least a typical developer. And the way we work, we usually keep everything in code. Like we use continuous integration, we use Jenkins. We don't do too much of it, like a site building Drupal work. More often than not, if you create something in the Drupal interface, you have to put it to code, which on Drupal 8 we use features, on Drupal 7 we use features, on Drupal 8 now there's content management, config management, exactly. And we use that, and we export all that to code, and then we can easily redeploy it to all test environments. We can easily then, when it's tested and it works, we can easily redeploy it then to production without manual intervention or redoing the work on each single environment. So we use dockerconsole. It's a script that helps us a bit manage this process. I can kind of show you how it works. So basically, when you have a website, when you have a Docker environment, you have some images. You might have Apache and PHP. You might have MySQL, which you saw. You might have Apache Solo. You might have a mailer or a mail catcher or some other image that does something else. You might have an image for backupping and some, many other images, which are a typical stack. And PHP developer is just a tool which we attach to this whole stack every now and then. I can show you how it works in a second. Okay. dockerconsole, this script gives us, well, it understands Docker Compose, so it kind of understands how this environment in Docker Compose is created. And it contains many pre-built commands that we would usually use, like dump the database, drush uli, so change password for admin user, all these other tools, or import a new database. And it enables us also to build a whole workflow from kind of like commands, and we can. So in here, this is like a custom type of a mechanism in which we can create a set of commands that will execute one after another. So in here, you can see that first command is build. It asks you for confirmation. Then it will run a composer install. Then it will actually execute a command which is this. And this command is defined here as some other commands, like drop the database, create, import, enable a module. I don't remember that one. Exactly, probably so. Yeah, cache rebuild, update the database, change password, and create a one-time login link. And I'll show you how that works in a second in Jenkins. And you can create, for this particular server, you can create such a build mechanism. On a different website, you might not want to drop the database and import it on every second build because the database might be too big, or it might sit someplace else, and you just connect to it. So you just delete these lines. You might not want to clear cache, or you might want to do something else. And you can just like Legos, you can create on each project these chains of commands. dockerconsole is available from pip, so you can try it out yourselves. We maintain it there. Okay, so let me show you a small demo now. So it has a abbreviation for decon, and like you can actually, so you have some available actions here, and you can add to those by creating your own, as I described just earlier. So, for example, if I, and in here, let me just, so these are my commands for this particular demo application, and if I run it, it will actually install Composer. It will, so say if I did a git pull, right, from a repository just a moment ago, some other developers were working, I don't really know what they did, but I want to have the latest up-to-date version of what they did to start working on some other features. I would execute decon build. It would ask me if I really want to do it. Sorry. Right. I actually have to, because I closed the images now. So now. Okay. And it will just execute everything. It will import the database right now, because I usually you have some sort of a database dump somewhere. We keep it. We have a special directory for it where we usually keep it. You can specify all that here. So we usually keep it in the just like a tab of a database, and it just executes one command after another. Cache rebuild now, and so if somebody wrote an update to a database, so it would change schema or something, or populate some fields with some new values or whatever, that would be executing right now. We don't have any new updates. It's changing the admin password to, well, here 123 because it's my dev environment to make it easy for me to log in. And it executes a one-time login link so that I can actually just click it and just log in.
How much faster is Docker compared to VirtualBox?
It's much faster. It doesn't work great on Mac, because on Mac it actually works really well on Linux, where it doesn't really give you any overhead. On Mac it gives you an overhead because on Mac it actually launches a Linux virtual machine within which Docker is run. So on Mac it gives you some overhead, but it gives you the overhead of the virtual machine. Doesn't give you the overhead of Docker. On Linux, which we usually use in our daily work, doesn't give you any overhead. So you can have multiple images, multiple projects running all at once on your machine, and they don't really give you any overhead as such. So they don't reserve memory that is kind of taken from your machine, unless there's a process running on one of the containers which is doing something intensive. You don't really even feel that there's some sort of a slowdown of your computer. So this is also really good. As a virtual machine, there's also always a problem. How much to give it, how much memory to give the virtual machine, how much to leave for your other tools that you're launching, and you're like, okay, this goes really slowly, so I'm just gonna give it 2 gigs, and then you're kind of reduced on your host machines. You don't have it here. You don't have it.
You also don't assign CPU cores?
You can in Docker you can do it. In Docker Compose you can actually assign it limits. It has access to all your memory available if you don't limit, but if you can limit it so that it can use 1 core or 2 cores, or you can limit the memory for a particular image. So for example, you might say Apache might just have 515 or something like that.
But you don't do that normally, is that right?
No, well, you would. I don't do it on dev, because on dev I just want everything to work as fast as possible. But you can do it in production. I would recommend to set some limits so that something awkward doesn't kill your whole server. Okay, so this works now. Okay.
Maybe a short thing to talk on Mac. Why is it slow? Also, you can recognize if you use the local file system, if you're sharing files between your host system and your container, you will notice it will get very, very slow once it uses those files. That's because of the OS X file system. But nowadays it can work pretty nice with less overhead if you use Docker machine in conjunction with it. That's a quick hint for Mac users to speed up performance.
True, that's true. That's true. Okay, so continuing, I wrote just a small conception test for my Beacon, for my demo store, which adds the product to the cart. I'm just gonna kind of launch it here. Just one test. Again, not too much setup, not too much configuration. It just executes a test. And will it pass? Then it's off. It takes a bit time, right? Because all the caches are cleared, everything is cleared. So this is the first launch of the service. Okay, in the meantime, maybe I can show you how it works on a Jenkins instance. Okay, so here is a Jenkins setup. Configuring this is fairly straightforward. I mean, Jenkins also can be a Docker image. You don't have to configure Jenkins and play with all the settings. You can just launch a Jenkins Docker image, and you can use Jenkins kind of just, in half an hour. Right, so these are the commands that are being executed here. So I'm removing the old database, moving a new one from some place where we every now and then dump a production database to have a fairly new one. Some other popular, like you can Docker Compose can read from environment files, so you can use that. And then I'm just updating images I'm building and I'm launching a test. And whenever there's a git push to a particular branch that I decided to use, for example, here is the master of my decon demo project, a build will be triggered. I've launched, because I did this presentation once already. I had some on our Drupal Camp, by the way. So here you can see the console output from the latest build I was doing. It actually just shows you all the output up until everything. And then you can see also the test results. And then you can see that test results, actually this is, okay, so this is actually, okay, so the test I run locally, the test passed, okay, one test, 3 assertions, brilliant, and this is the output from this test. So it says, so it was just a simple test that I'm on the home page, I see Docker demo text, I click add to cart, and I see Docker console training added to your cart. Right, so basically it's just codeception, just with Selenium it just clicked here and it just saw that the product was added to the cart. And it produces me a test result which shows that everything is working. And all this is really easy to set up. Like we were doing this manually before and it was taking ages. Then, so you create the environment locally, you set everything up, then you had to go to Jenkins, set everything up there, set up databases that Drupal could connect to, set up virtual hosts, set up all these other mechanisms. Then you needed a staging environment for the client, so you had to repeat the process. Then you needed another staging environment for a feature branch, you had to repeat the process. Right now, we just add a new build, we just specify a host that we wanted to use in configuration and just kind of launch it, and it works immediately. All the URLs are auto-discovered, everything. The routing to the new build happens automatically, and everything just works. And it saves us massive amounts of time, and it just works. It doesn't really break that much. Right. Moving on, do's and don'ts. Just a few. Docker is great, but when you launch an image and then you stop it and remove it, all the data that was in it is gone. It's really easy, especially if you're new to Docker, to forget about that and have your database, removed. So don't hold data in containers. Hold data. Docker now has a notion of volumes which you can use, and they are more persistent than the containers. Or you can map, you can map your local file system, so your host file system folder onto the Docker or a file into the Docker file system. And when you destroy a container, this volume kind of stays and data within it stays. Don't hold multiple services in one container. So especially if you use the VM, you might be inclined to go in and install everything into one image or one container. It seems easier at first, but in the long term, it's actually really difficult to maintain, and it's not the standard practice, and we don't recommend it. If you do it, maybe you can do it for a test purpose of some software that you haven't used or something that needs a few additional libraries. But in general, I'd recommend to try to use Docker Compose immediately if you need two things. So if you need a MySQL and some sort of an app that needs a database, try to already immediately combine to containers, to images. It's much better. And use code for config, right? So don't shell into a Docker image, install softwares, and then save it, because you can also do that. But you can use a Docker file which describes the process of creating a new Docker image with additional data in it. Use that and use Docker Compose. These two things make it easy to understand to everyone that uses the service what this image actually is, how it's built, what sort of software it has on it, and it will save you a lot of time and pain if you follow this practice. It's just very transparent and clear to understand to everyone what's happening. There I showed you the demo already. So thank you. Do you have any questions?
Using for networking because I couldn't see any port mappings or exposing stuff to
Yeah.
interface. How do you do it?
We use a Nginx proxy. And Nginx proxy is an image which, like I have it, so I run it in a daemon mode, so it's immediately launched. And whenever I specify virtual hosts in any Docker file, it automatically auto-discovers them, and this image is it maps port 80 and port 443 this to the host, and this then routes. It's more complex setup, but it helps in such a way that when I pull a new image for in our environment, like a new project, I don't have to go to, and I don't have to set it up that much. It just works automatically.
Yeah, I'm familiar with the Nginx proxy, but I always had to define network, like an external network, in one of the containers, and then in my other projects I have to wire these two external networks together. So, yeah.
Maybe you're using, because this is Docker Compose version 1.
Yeah.
Are you using in version 2? You already have private networks. You actually have to map them manually. Yes.
Yeah, so the configuration is more
Yeah.
close in version.
Yeah, you can then add each image to the new network that you created.
Yeah, okay.
You have to you can type it one into the console, and it works as well.
Okay.
Any other questions? Okay, so I have 3 questions for you, and I have 3 rewards. First off, where are you going to be in May next year? Very well. So you win the first reward.
Hey, dziękuję bardzo.
You're welcome. Right. Another question is, what's the name of the script that we created and we're using to manage Docker?
Dockerconsole.
I think you were first. And last question. I should have prepared them before. It would be easier. What's the name of the file which describes how the images are linked together?
Docker Compose YAML.
I was ready. Here you go.
Thanks.
Okay, thank you very much. If you have any other questions or you wanted to, use Docker Console, try it out. It's all available. All the images that we use are also available. You can email me as well. I'll be happy to help. Thank you very much.